we're going to do the first free response problem for review day number 8. And it gives us this very crazy looking graph, which is done with these line segments until you get to 3, and then all of a sudden it's this parabola, and they give us the equation of the parabola down here. All right, so it says if f of 1 equals 3, what's the value of f of negative 5? So this is one where we're saying f of negative 5 is going to be what it was at 1, which was 3, plus how it changed from 1 to negative 5 based on its derivative, and g is the derivative, so we're going to be integrating g then. Okay, and so this is going to, if we go from 1 back to negative 5, that's this triangle here. 2 times 1 divided by 2 is 1. Then it's nothing here. Then it's this triangle, which is a height of 3, base 1. So this is 1.5. And then it ends up being this square here, which is 1, 2, 3 by 1, 2, 3. So that's 9. Now, we're going from 1 back to negative 5. So that means that these negative areas will become positive. This positive area will be negative. So we'll have our initial 3 plus now 9 and 1, that's 10.5 minus the 1 that's there, and we end up with 12.5 for our answer. So they gave us a point for this integral set up here, and they gave us a point for that answer. Then it says to evaluate just simply g from 1 to 6. So we're basically going to do the rest of it now here. So we're going to need a little bit of room to do that. I'm going to do it down here. The integral of 1 to 6 of g will be the integral from 1 to 3. That'll just be this square here, okay? And then it'll be the integral from 3 to 6 of g, which is the parabola. So then I'll have to bring in the actual equation. So we're going to be doing part of it based on what we see and part of it off of just an equation. So the first part is easy enough. That's just that square 2 by 2, so that'll be 4. And then I'm going to have to integrate this. Now you can do this as a u sub if you don't see it at first, or you can, because x minus 4 is just kind of ordinary enough, you can do this as x minus 4 cubed over 3. If I take the derivative of that, the 3 would come cancel there, drop it to a 2. The derivative of that is just dx, and so I would get back to what I have up there. Okay. Now at this point I got to evaluate this, so I've got this 4, and then I might just take that 2/3 out and do the x minus 4 cubed on its own. So if I put the 6 in, 6 minus 4 is 2, 2 cubed is 8, minus, put the 3 in, 3 minus 4 is negative 1, negative 1 cubed is still negative 1. All right, and so I'm going to get 9 out of this. 2/3 times 9 is 6, and then 4 plus 6 ends up giving us 10. And that's the answer there. So how did they do this? They gave us 1 point if we recognized that we needed to split it at 3. They gave us 1 point if you had a good integral of, if you integrated this correctly, and then they gave us 1 point for the final answer. All right, so 3 total on that. C says, on what intervals is f both increasing and concave up? Now, f will be increasing if f prime, which is g, is greater than 0, and will be concave up when f double prime, which is g prime, is positive, or when g, let me put it differently, or when f prime, which is g, is increasing. Okay, so really what we're interested in is to look at when is g both positive and increasing. When it's positive, f will be increasing. When g is increasing, f will be concave up. So we look at our thing, and g is positive all along in here. It's increasing from 0 to 1, and it's increasing again from 4 to 6. And we could say that's where f prime, which equals g, is positive, and f prime, which equal, or positive and increasing. Maybe it would be best to just say positive, now that I think about it. Okay, they gave 1 point for the correct intervals and then 1 point for the correct reason. All right. And then the last one says find the x-coordinate for the points of inflection. Now, a point of inflection is when your derivative, which is g, switches from increasing to decreasing or decreasing to increasing. Okay, so we have nothing going on here. Then it increases, but we don't have a specific switch, right? It just keeps flat. Then it goes up again, and then it stays flat, and then it comes down. So while the concavity is switching, there isn't a point where it happens. It's over time, it stays flat, and then it switches. We need one specific point, and the only place that happens is right at 4, where it switches from decreasing to increasing. So for D, we would say at x equal 4. That's where f prime, which equals g, switches from increasing to decreasing. So you got a point for that answer, x equal 4, and a point for the explanation.